Okay, welcome back. We're still looking at timers. Now, I've programmed another rung where I have an digital input 4, and when it's true, I'm going to start a 5-second timer. And it's going to turn on a light, digital output 3. It's straightforward. I can download that, and it should work. Download. Okay, so I've got my simulator, the output's on, and after 5 seconds my light came on. I turn it off, go back to 0, turn it on. 5 seconds later my light will come on. Pretty boring stuff. Okay, but let's say that I want that to be delayed coming on for different periods of time. How can I make that do that? Well, I could put a bunch of different timers. That's a lot of work. So what I'm going to do is I'm going to create a new rung of logic. And I've already written this, and I'll save us some time. And what this rung does is it changes the value here if I change this timer to bake time. And bake time, I'm going to go and open this up to my variable selector. I've created some variables, bake 1 and 2, and bake time, of the time data type. And then, under my initial value, I have ascribed a certain amount of time. So bake time, the default, is 10 seconds. If bake time 2 is called for, then it's 5 seconds. If bake time 1 is called for, then it's 15 seconds. Okay? So I have an instruction here called an MOV or move instruction. So when this is true, bake time will have 10 seconds moved in by this move instruction. So if I were to go back to here and say, okay, I'm going to have no initial value, and left that 0, it would get overwritten by this instruction to 10 seconds. But I'm going to say that 10 seconds is my default time, so I'm going to say okay to that. If digital input 5 is true, then the bake time changes and it becomes bake time 1 time. If I hit DOI 6, it becomes bake time 2. The only issue is, when I select this button, it's going to also put that time in, which is not what I want. I want them each button to change the amount of time. So it's like a selector switch. Okay, that'll move that, that'll move that, that'll move that. So my process time will actually, my program time should change, and it should start to count. When I switch positions, it'll reset itself because that'll be momentarily off, and then that'll be true. So let's just download that and see if I'm on the right track. Now I'm going to download with project values, and that's going to put those initial values into our program. Okay, so right now the output is, okay, that's off, that's fine. So I'm going to toggle 4 and put 10 seconds in there. And 10 seconds later, my light's on. Huzzah. Okay, so now I'm gonna, it's a selector switch, that would be false. So it turns my light off, and then I turn 5 on, and now it's 15 seconds. I'm going to turn that up before it's done, and I'm going to go to 6, and now it's only 5 seconds. So each time this is toggled, I am moving a different value into our timer. And our output is being delayed a little bit longer. Now, if I wanted the light to stay on while it's timing, not after it's time, like I want it to actually, do something for it, I don't want to use an off delay because that means I have to toggle it on and then toggle it off, and then it'll start to count. And I want to make sure that it's still true while it's counting. Oh, geez. I'm going to have to change it. Oh! I just remembered how I can do this. If I want this to be on while this is timing, while this first timer that's being controlled by bake time, I just need to I'm calling on my buddy Reggie. So I'm going to go here and I'm going to put in a precondition. And I'm going to put another precondition in. And this one, I want it to control the output. I'm going to think this thing very carefully because I don't want it to be wrong. I think I'm going to take and do a separate run. So this is my my timer, and I want, when it's true, I want Reggie to start counting for me. Okay, that's good. And I want to move this to Reggie, so when timer 1 is timing, turn that on, and I want it to only be on for 5 seconds. So I want it to be on when this is not finished. So I'm going to use the same, but I'm looking for it. So when I've been told to start counting, that's my rising edge, I've been initialized, but I'm not done. So during that time, I want this light to be on. When the timing is done, just to prove that it has finished, I can put a second digital output, and I'm just going to call that digital output 4. So I'm going to go and hit my variable selector. Oven's on. Now I'm not going to call it ovens off because that's going to be confusing because it'll be off if there's no power. So I'm going to say ovens done. Okay, that makes sense for those two. So that'll be on when these two conditions are true. Okie dokie. So when my timer is actually counting and it's not finished, I'm going to have this light on to tell me that the element's heating up. And then when it's finished, it's clocked out, then this is on. So now that I have these different bits, the different time allotments should be entered in, and I should be ready to go. So let's see if I've accomplished what I'm after. Okay, so I've got a couple of bits turned on. I'll turn that off. Okay, so my output is turned off. So that was a 5-second timer, and by the time everything was finished, my time was done. So I'm going to turn on my bit 4. and leave that on. And it's put 10 seconds. So my oven is cooking for 10 seconds. Oven's done. Elements turned off. Awesome. Okay. Now the oven's no longer done because we've toggled it. I'm going to move the next value in of 15 seconds. Oven's cooking. Oven's not done yet. And 15 seconds is complete. Okay, I had that on for 15 seconds and I turned it off. Unlike an off delay timer, this finishes at the end of our time count as opposed to waiting for it to be toggled to turn off and then carrying on for a certain amount of time. So let's just do this one more time. We'll see if with the 6-second timer, number 6 is putting 5 seconds, oven's on for a short blast, and done. So what this has done for us is we now have logic doing two things for us. We're using a single timer to control an event, but we're using an on delay to behave like a duration timer. In other words, we want the action taking place while it's timing. And while we're doing this, we don't want the timer to be triggered, left on and running, because an off delay timer, which will be in the next video to show you the difference, will be on instantaneously, and then when you turn it off, it stays on for that off delay period. Okay, so in this case, we're using our internal rising edge bit and the done bit to control an output while the device is being timed. So while our timer was set for 5 seconds, while it was counting that 5 seconds, our oven element was on. Once that time had expired, I get the oven's done light come on, but my Q bit now turns off that output. On any given internal coil or any internal output that you create, whether it's a timer or a counter, remember that it is has a dual nature to it. You can accept it as is, or you can say, hang on, I want to examine it while it's not in its current state. In other words, if my timer is finished, I want to know it. If it's not finished, but it is timing, I want to look at it. And we use the not logic, the reverse coil, or the reverse contact to make that happen. Another way that I could have done this, and I could have made it much simpler, instead of using this, and I wanted this to be on only while it's timing, I could select and make that into a not coil. The problem with that is that this not coil is going to say that my oven is done regardless of any time. If that timer is not timing, then my oven's done, which is not what I was after. So we're just going to leave that and use this bit to make that decision for us. I change the time by making the actual time a variable of the time data type, and then I use logic to move a new value into that bake time. On any of these instructions, counters or timers, as long as you maintain the correct data type, you can manipulate on the fly. You can make the logic dictate how long that timer is going to be counting. How many, if I were making, for example, if I have a conveyor system that's running and I'm baking bread, the amount of bake time that I want the oven to be on might be, if it's air drying, for example, might be only 10 minutes for a French stick, and it might be 15 minutes for a whole bunch of Kaiser rolls. I may be turning around at the same time and saying, well, hang on a second, that's going to be impacted by the number of Kaiser rolls or the number of French sticks I'm making, and I might want to adjust my time. I can use product counts to adjust that time based on that. And I would have logic similar to this with the move instructions to actually change the time that I want so that the timing is always perfect and I don't have to sit there and constantly adjust my cooking time. I just have it pre-programmed. When the process changes, my cooking time changes. In our next video, we're going to look at quickly some of the other timers, the timer pulse and the retentive time, and we're going to look at using the TOF timer as well.